Well, we're starting off on a unit on logic. It's an introductory unit. The objective of this unit is to let you come to understand some of the basic concepts in Aristotelian logic, which have really formed the basis of even contemporary logic. But a little more of that later. First and foremost, let me encourage you to have your worksheet for this unit printed off and in front of you as you're watching this video. The structure of this worksheet is different from the others. It's more short answer questions, fill in the blanks, multiple choice. It's getting you ready for a test on the logic side of this course. And I'll make some comments about the way the slides are set out and the way the questions in the worksheet are set out as we're going through. So you may want to have that with you. So just take a moment now to print off that worksheet and come back and we'll get started on this particular presentation on logic. By now I hope you have your worksheets with you and I'll talk about those as we're going through. So let's just remind you that the textbook's useful to you, the PowerPoints, and you can look at that. This slide outlines for you the issues you're going to have to learn or know because they're going to be foundational in our discussion of people like Augustine and Aquinas and Descartes, to some extent Locke and his followers, but very much so when it comes to Kant. So these basic concepts will be useful to you in a number of different ways. I'll come back to them at the end in a little more detail then. But let's first begin by thinking about all topics of study, all university topics, history, philosophy, all of them unfold chemistry, science. They have a history. And what we do today has been built upon what's gone before. And when it comes to philosophy, and in particular logic, there is a history of addressing the question, how can I persuade you of something? For example, I'm trying to persuade you to use your worksheets, to do the course systematically, because I believe that will help you to be successful. I want you to be successful. How can I convince you of something? Well, today, as in the time of Plato and Aristotle, there was a group who said what really matters is that the art of persuasion and the skills of persuasion, known as rhetoric, is what's important. These were the sophists. They were infamous because they had a sort of argument that went something like this. Today I convince you that I can show you and train you how to present an argument to persuade people to believe this. And tomorrow I'll teach you and show you how to have an argument to persuade those same people this. And it was argued they didn't believe in truth. And of course this was a frustration to people like Socrates, Plato and Aristotle. They were concerned with truth. And they were concerned that the justification, the arguments which convinced you of something, had to have soundness, validity and truth. They were committed to these positions. But the question was, how do you do that? For Socrates and Plato, the answer was showing you the validity of concepts and enabling you to say, I get it. It's, again, going back to the famous 2 + 2 = 4 illustration. Once you've seen the concept 2 + 2 = 4, you don't need any evidence for it. You can understand it, you see it, and you may have been taught it at school by showing you, here's 2 blocks, and your teacher taught you, put 2 blocks over here and 2 blocks there, you see they're the same. Again, she was asking you to see that we're the same. You look at it, I can see that. That's observing a concept. Aristotle wasn't convinced of these concepts. Aristotle wants to argue that it's important that you have to use reasoned analysis. And to that he says that what's really important is to realise that what convincing is made up, an argument is made up really of a series of statements, the end of which a person goes, that makes sense. And what's more, Aristotle wanted to be in a position where he could say, that doesn't make sense, but you can see it's, if you like, logical. And let's go back now and remind ourselves of what we looked at in terms of the categories. Now we're back on the subject again. But if we're to understand Aristotle's approach to logic, and he's the foundation here. You remember that he started off, and remember in the course we said, you have a single pure substance, man. And what you do with language is that you bring to bear other categories which help you to make sense of that substance, that primary substance, man. This man is 10 feet tall. Here we have a primary substance and a secondary substance. And what's important here is that the second quality here, the second substance, the second category of substance, I beg your pardon, the second category quality is adding something to the primary. Just as in any sentence you learn in grammar, it is the predicate that adds something to the subject. The subject of the sentence is man. The predicate is 10 feet tall. The predicate is adding something to the subject. And so Aristotle said a statement is made up of terms. What's the term? Man. What's the second term? 10 feet tall. So you have two terms. One is in the subject position and one's in the predicate position. Hence, he expressed that in S and P. And he says that the predicate always adds something to the subject. Now, with that grammatical lection behind us, let's move on to make a development of that. Remember our previous man was 10 feet tall. We want to move from that particular statement about that man to a universal statement. And Aristotle insisted that there were some statements that are universal, that are not true by definition, but they're very persuasive. They have a degree of certainty in them. And for example, the statement, all men are mortal, is a very persuasive statement in and of itself. You can infer from that all kinds of things. And he said these universal statements are certain, and you build from certainty outwards. Excuse me. And so these are universal statements. And he said you can look at universal statements and make certain absolute observations. These are the three laws of reason, and we'll come to those in a moment. So the universal statements, contrast that with particular statements. Previously we talked about the man who was 10 feet tall. Let's talk about a particular statement in the form of some men live for 90 years. This is a particular statement about a particular group of men. And we might have great confidence in it, but it's still not in the same sense of certainty. For example, I think you're fairly convinced that some men do live to 90 years of age. But the statement, all men are mortal, you can sense, I think, is a far more universally true statement than some men live to 90 years. It's still hazy, whereas all men are mortal is not. It's very clear, it's not mixed, it's pure, it's clear. And on that basis, Aristotle insisted that these universal statements, all men are mortal, help us understand that there are some things you can absolutely say about statements which have a universal quality to them. And the first is that those statements cannot violate the law of non-contradictions. Something cannot be and not be at the same time, in the same place, in the same respect. Example, men can be both mortal and immortal at the same time, in the same place. That's clearly a nonsense statement. You can't be mortal and immortal at the same time. The basic category of mortality means dying, death. Immortality means don't die. Those two things don't fit together. But Aristotle would say that that same idea, and one of the things you'll notice about the three laws of reasons, they're really the three laws of reasonable thought, they're reciprocals, is that the law of the excluded middle says it can't be and not be. Something is or it isn't. Men are either mortal or they're immortal. It can't be Two different things. And of course the law of identity follows on from that again. Men are mortal. Now, there's a lot of debate today about the three laws of reason. The point for us, though, is it's introducing to us the concept of universals. And we'll just take a pause here for a moment. Right, we're back again. It was a longer break than I expected, but not necessarily for you, but it was for me. We were focusing on the three laws of thought and reason. And now, briefly, let's look at the square of opposition. You'll find a different model for this diagram in the textbook by Melchett. What I want you to see here is that what we have on the top line, all S are P, and over on the right-hand side, no S is P. What we have here are, in a sense, universal statements. And down the bottom, we have particular statements. Now, these statements are in the form of deductive reasoning, and these are inductive reasoning. And with that in mind, let's now come to the next slide. Deductive reasoning is an argument from the whole to the part. All men are mortal. Out of that, you can develop a number of terms or statements, using terms and statements to infer certain things, which we'll see in terms of logic in a moment. Inductive reasoning, on the other hand, moves from the part to the whole. And in particular, inductive reasoning is perhaps the form of reasoning most common to us in ordinary day experience. A fun illustration would be, of course, the great detectives who take a piece of evidence and they take this particular piece of evidence and infer all kinds of things from it. The classic example, of course, being Sherlock Holmes. And of course, it's always Dr. Watson who marvels at the wonderful inferences and the wonderful reasoning displayed by Sherlock Holmes and his inductive reasoning. There's going to be an important distinction between those two. We'll come to it in a moment. But first, let's just pause and, in a sense, remind you that there are a couple of slides here in white. These are simply giving you some background of the development of this early form of Aristotelian logic. Began with Aristotle, refined by Cyprius, and also by Galen. I'll let you have a look at those things. What's important for us is we need to be able to build upon this important form of reasoning, deductive reasoning, because it is the basis for logic. Not inductive. Inductive won't work for logic, but deductive does. And we'll try to show you how it does. And in that regard, we're going to use the tool that comes to us from classical logic, namely the syllogism. The essence of the syllogism, or the contents of the syllogism, it's made up of three parts. Two parts are clearly visible, one part is invisible. The visible part are the premises. The premises, this portion here. And then the conclusion. All A are B, premise number one. All B are C, premise number two. Therefore, all A are C, conclusion. The force that drives you to say, yes, all A are C is clearly obvious, that's the inference. It's the invisible sense of the necessity, the necessary connection between all A are C. And it's this which really defines the type of inference being drawn. Now, as far as we're concerned, in this course, it's important for you to know that a syllogism is made up of the premises, the conclusion, and the inference. And from there we'll come back now to this distinction between deductive and inductive arguments. You can look back at the square of opposition, if you like, either in the textbook or on the screen. Go back in the slides. And what's important is that an argument based on deductive arguments using logic is going to produce a conclusion which, if in the valid and correct form, is certain. Now, we're going to see later on that's a big distinction between certain and true. But it's important to see that that gives us a conclusion which is certain. Whereas inductive arguments, notwithstanding Dr. Watson's marvelling at Sherlock Holmes, until Sherlock Holmes goes out and establishes the validity of his inference drawn from an inductive argument, until that point in time, all Dr. Watson is looking at is an argument that is probably true. So it's the difference between certainty and probability. And of course, it's important in the study and evaluation of an argument to be able to justify your argument as being certainly valid. So obviously, if you can use deductive reasoning to do it, you're going to have a very powerful argument. And that's the purpose, of course, behind the rules of logic. Well, back again to syllogisms. If syllogisms are the heart of the matter, are they all the same kind? No, they're not. We're going to look at three fundamental distinctions: the categorical syllogism, the disjunctive syllogism, and the hypothetical syllogism. And you need to be able to distinguish and recognise these three. This is where your study notes will be helpful to you, and I'll talk about that a little more as we come along. First and foremost, let's look at the categorical syllogism. You can see here on the screen, all A are B and all B are C, therefore all A are C. We've been using this one a number of times. But I want you to notice the example I've given you. It may look a little strange. For example, I'm not using all with the first statement. Socrates was a man. But that is a universal statement because there's only one such person. It's the only possible. It is a complete categorical category. And categorical syllogism is about enclosing everything within a circle. All men or Socrates. Only one person. And we can say with certainty that he was a man. As a universal too, Socrates was a man. And then we bring in all men are mortal. And so we can make a conclusion. Socrates was mortal. Even though the word all is not used, you can still structure it. But the fundamental model is all A are B, but all B are C, therefore all A are C. Now, if you recall the square opposition, you understand that the top two were a universal affirmative and a universal negative, and the bottom two was a particular affirmative and a particular negative. And hence you can see there's a format. Universal affirmative, all X are Y. Universal negative, no X are Y. A particular affirmative, some X are Y. Or a particular negative, some X are not Y. I mean, that's very straightforward. So again, have a look back and play with that in relation to the square of oppositions if you're not clear about it. Let's go on and look at the next type of syllogism, the disjunctive. And again, you'll see that I'm starting from these universal ideas. And either it is X or Y. You'll see that's representing that law of the excluded middle. Either it's X or Y. It is not the case that it's X, therefore it's Y. And I've given you the other example on the right-hand side of the screen. Either it is John or Bill. It's not John, thus it's Bill. I think I said that correctly. It's either John or Bill. It's not John, therefore it's Bill. And similarly, you can turn that around. Same fundamental idea. It's either X or Y. But this time it's not Y, thus it's X. Again, profoundly obvious. Now, what is important for you to note, especially as you're looking at the study sheet, that questions and logic are not necessarily set out in the form you see, either the form here for a disjunctive syllogism or here for a categorical syllogism. But what is important is that if you get a question which is in the form of a sentence, a logical statement about summing up an argument, which you need to take that argument and put it in the right form. And the easiest thing you can do is convert them to this form for disjunctive syllogisms or this form for categorical syllogisms. And with the other, we show you. In other words, translate them in the form of either it is John or Bill, or it's John, Bill. Seeing the structure, because form is what's so crucial in logic. It's form, form, and only form. So we've looked at categorical syllogisms, now disjunctive syllogisms. Let's move on to hypothetical syllogisms. Again, here is a straightforward hypothetical syllogism. If X, then Y. If Y, then X. Therefore, if X, then Z. And again, the right-hand side gives you, if I fall asleep in the morning, I'll be late for work. If I'm late for work, they'll call it to my attention at work. Therefore, if I fall asleep in the morning, they will call it to my attention at work. And that is a perfectly valid argument based on hypothetical syllogisms. So again, it's important to structure any question you get on logic into this form. There are questions in the test sheet, the worksheet, that you're going to have to put into that form to be sure of the answer and to check if they're in the correct form. Now, there are pure hypothetical syllogisms, and that's exactly what we've been talking about. All the elements are hypothetical. That's a very simple, pure hypothetical. But the matter doesn't simply end with pure hypothetical syllogisms. We can go on with mixed hypothetical syllogisms. Very common and very useful, by the way, where one premise is conditional and the other is categorical. Now, in red you'll see at the bottom left-hand side of the screen, if X, then Y. Hypothetical. X, that's a categorical syllogism. You're saying, hang on, that's not like all X are Y. But what we're saying is, this is the case. It's a universal statement in relation to the previous premise. Therefore, Y. The example you see on the right-hand side. If it's sunny, then it is daytime. It is sunny. Therefore, it's daytime. And again, if you're asked a question in a study sheet or an examination or a test, always take a moment to put it into, make sure you put the question into, you rewrite the question in the proper format and test it out. That brings us to an important set of distinctions between rational, irrational, and non-rational. Now, in common speech, we would say that argument's rational, that argument's irrational. Well, this is not the way we're using the words here. Rational has a particular meaning. Rational means it conforms to and meets the requirements of the laws of thought and reason. In other words, it's a logical argument using deductive statements and put together meeting all the requirements of form of logic. Irrational statements, on the other hand, are arguments that are totally incompatible with general experience and the requirements of the laws of thought and reason. Totally incompatible. These are the crazies. But non-rational is important because this is Sherlock Holmes. This is inductive reasoning. Reasoning while not conforming to the technical requirements of rules and logic. Nevertheless, is persuasive, different, and sometimes even higher. And what's important here is that most of the work you'll read and arguments you'll read in science are inductive and hence non-rational. But it's important to realise that distinction. By the way, if you do a course on logic, you will discover that later developments in logic have been developed to try and make ways in which you can put arguments that are technically non-rational to meet some of the requirements, at least, of the laws of reason, so that they become arguments which you describe as certain. And that's the task of modern logic, to expand the breadth of which logic can be applied. But that's not our purpose here. Our purpose is to see these distinctions. Now, the last important distinctive, and a very, very important one, is the distinction between truth, validity, and soundness. You could say reality, validity, and soundness, but truth will do for us here. And what's important here is that the conclusion of a valid argument, a valid one which meets the requirements of form, the conclusion of such an argument can only be asserted with certainty as being true. You can only assert it as being true on the basis of that argument if all the premises are shown to be true. And by the way, that doesn't mean that a conclusion which is true means that the premises, ergo, had to be true. You may have a true conclusion, but false premises. But what you can say is the converse. If the argument is in the valid, correct form, and those premises of the argument are true, then you can assert the conclusion is true. And if you think back to algebra, you'll see that's exactly the same principle. If you have all positive statements in a formula, then the conclusion is going to be positive. One negative assertion will make the conclusion negative. It's the same idea. Now there's validity. Validity has to do with form. Any argument that meets the requirements of form, strictly speaking, is valid. But it may not be a true statement. And indeed, it's possible, indeed rather easy, to show arguments that meet the requirements of form that are clearly not true. So truth and validity are two different things. And that introduces another distinction, which really is important for inductive arguments, but it's important to note here, and that is soundness. Soundness has to do with the power of the argument. And that's really what Socrates and Plato were asserting. We'll set before you the concept and you can just see it's true, it's powerful. Well, that's true in other forms of arguments as well. So these are important distinctions. You need to know there's a difference, and hence I've got definitions there for you. You should use those. I've already mentioned the fact that deductive and inductive arguments are very different. Deductive arguments, the sorts of arguments you get in mathematics, whereas inductive arguments are the kinds you get in chemistry, science, and the like. And hence, there's some interesting fun questions here. I'm not going to get them in this course. I realise I've left this slide in, but I'll leave those things there to you. Just a note, an interesting question. What does appeal to facts mean? Well, facts are interesting things, and people want to argue certain things are facts without any real justification for them. But let's leave that where it is for the moment. Fallacies. One quick brief word on fallacies. In the study of logic, mistakes in form are called fallacies, and all classical arguments can be categorized as either deductive or inductive. Mistakes of arguments in the deductive form are called formal fallacies, and inductive arguments in fallacies are informal fallacies. An example of informal fallacies would be the ad hominem argument, an argument which argues against a person on the basis of their race or colour or age or sex or anything you bring up that's pejorative, and so you can't believe you because you didn't go to the right college. That's an argument against the person ad hominem. And that brings us back to our summary. You need to know the nature of an argument. Why is a conclusion true? Why is it valid? When is it true? When is it valid? When is it sound? What are the three laws of thought? What are the components of an argument? Remember, there are three, the two visible and one invisible. The difference between deductive and inductive, logical entailment, what does that mean? Well, that's the invisible sense that an argument is valid because it's in the right form. Logical entailment is the structure of the argument. The various forms of syllogisms, and again, back to that distinction, truth, validity, and soundness. Please make your way through the study sheet. That'll be very important for you. You can see it's a different structure. I hope you'll find that helpful. And we'll close our lecture here and